In this video we investigate, we find odd parts, lots of hammering, the lathe, some grinding and spark, more hammering, plenty of drilling, more cutting with spark, more hammering, lots of noise, lots of welding, more spark, more hammering, more welding, disappointment, big drills and little drills, and lots of heat and sizzling. Hello guys, Craig from Fixitfallows, and I am here with my good old trusty Draper pressure washer, but it's packed up. It's making a bit of a racket. Let me see whether it will do it. Let me show you. It sounds more like a hoover now, and then there's definitely something loose inside. Maybe the pinions come off the motor. There must be a motor in there, right? How else would the pump work? We're going to open it up and have a look. This is a Draper 1700 watt. There's the stock number, part number. I want to take off this black backing, and it has got a total of 13 screws that I've got to take off, but there's also a hidden one. So on the side there where you got your lance holder, you just need to knock that up. Reveals a 14th screw. So I'll get all those undone and we'll have a look inside. That's all the screws undone. Looks like I've got to take off the hose attachment and the high pressure hose attachment. So this is a simple case of undoing this plastic nut here. This one looks like there might be, yeah, there's like a U-pin through there. If I pull it out, that should slide off. Little screwdriver in there. There you go, that come off. Okay, I just need to get a wrench on there. Just get that off of there. That nut off of there. There we go, and the case lifts off. Okay, so what is in here? That is a hex head bolt that is sheared off. From where has it sheared off? Okay, so there's 3 hex heads on there. They're all in place, don't like okay, I can find, there we go. That's where that hex head's come from. So there's 1, 2 and the third one there. Yeah, we've got some sort of oil leakage going on. Right, I might have to dismantle this a bit further. Okay, so my take on this so far is the water goes in here, goes in there, that's the inlet, goes into this casting here, and then eventually comes out of here. This is the higher pressure out point there. So all of this plastic housing here seems to be a motor. There must be a shaft goes down there on some sort of impeller that draws the water in, speeds it up, shoots it out. That's my thinking there. And the very fact that one of those bolts has sheared off makes me think that something maybe a little bit catastrophic has happened inside there. But we won't know until we open it up. Okay, so the motor seems to be held in by this moulding here with a screw there and there. I'll do those. Yeah, the whole unit can come out. So we've got the whole motor unit set up like this. Let's get this bit off and see what that shows. Okay, so that's what it reveals. There's the broken off hex bolt, which we can get out no problem. So these appear to be some sort of like rams or pistons that get moved up and down in some sort of rotational pattern. So the motor spins, Then there's some sort of cam system in there that makes these go up and down against their springs, and they go into these receptacles here, acts as like valves. Anyway, that one there is quite rusty in there. Shall we clean that out, replace this bolt, and see whether it goes back together? There you go, it's coming out so easy because there's no head on it. There's no pressure keeping it tight, so it just unscrews straight out. Right, okay, well look, curiosity got the better of me. I'm thinking to myself, this one broken bolt can't be what's causing this to stop working. Something has caused this to break, something deeper inside. So I've got dismantling. Right, we've already taken off this section, haven't we? So this is the bit that actually controls the inlet water and the outlet water. And we've established that it does it by these 3 rods here moving up and down into those 3 valves there, and that creates the high pressure output. So how do these 3 rods move up and down? Well, having taken this off, there are 3 sprung loaded pistons rods there, and they just move up and down. Okay, there's nothing super special about them. They run inside this oil which I drained out of this casting. Now what we have inside here, it's a spinning disc, but if you can imagine that the shaft is perpendicular like that, that disc is set at this angle on the rotating shaft. So as the shaft rotates, this keel to disc there is spinning around at varying angles, and that is what causes these piston plungers to push up at different points of the rotation, pushing through these holes and into those valves at different points. This hex head bolt held this plate in place, and just as a point of interest, it has a reverse thread. I guess that's so it doesn't come undone whilst the motor's rotating. Let's fish that out of there. So let's get that bit out of there. Then there's a ball race. Okay, I fished that out of there. Okay, so there comes that, and that runs around in that groove in there. And then there's a corresponding grooved section there, and that comes out. Okay, and that sits on that rotating spindle there and interlocks that on there. So that shaft there must rotate, but then when you look at it relative to the motor, it's off-centered, so there must be a pinion gear on the motor, and there must be some sort of spur gear in here. So I've undone the bolts out of here, and this lifts off, and we find, there you go, there's a spur gear and there's a pinion gear. And the sad reality is that that is well and truly worn. There's a deep ridge in there, and then inside there, there's almost like a grinding paste now. So I've cleaned it up as best as I can in there. Is that some of these teeth have been utterly mangled. But that looks like to be a push fit on there. But the chances of getting that drive pinion and that spur gear being able to actually fit it, I don't think so. Right, well then, nothing ventured, nothing gained. I'm going to try and get that spur gear off, and I think I've got to pull this bearing off. So I've acquired myself this puller. So on the bottom of this puller there's little bits that jut out. They've gone underneath the bearing there, so they pull up, and then I turn this bar here, it pushes this thread down into the middle, and it should, in theory, pull this bearing off. So let's give that a go. Or it will pull the ball race to pieces. Well, believe it or not, it is actually moving. So let's carry on. There we are. The bearing is off. Right, the bearing's off. What does that leave us? Right, okay, I have managed to get this far. So the spur gear is attached to this shaft which passed through there, through that bearing. Okay, so when that was in there like that, I hammered down through there onto the shaft, and that hammered this out. So it looks very much like, so I've got to try and remove this now from this shaft. So I've either got to try and pull it off or hammer it through. So there we go, I've got it in a vise like that. I've got a big old club hammer and I'm going to hammer it through. There it goes. Okay, so it's just a pressure fit like that. So question is, can I get that gear from somewhere? Right, okay, so as you saw, I've got the spur gear off of that shaft and out of that housing. Now then, pinion gear, can I get that off? I shall try with this. Let's have a go. Okay, so I'm trying to use this puller on here in order to keep these jaws tight against the pinion there. I've had to make a little adaptation to these screws because they wouldn't tighten up fully, so just put effectively spacers in there so I can clamp them up tight. So now it's all engaging nicely, and it's just a question of, can I get this to pull off? What's going to give way first, the threads in here or that pinion on that shaft? The pinion is moving, the shaft is now deeper in there. Okay, as you can see, definitely made progress. Right, okay, at this point I've had to make an adaptation, right, because the shaft of my puller is, I don't know, that's probably, what is that, 6, maybe 7 mil, but the shaft that goes through the pinion is 6 mil, so this can't push down any further into the pinion, so I can't draw the pinion off. So what I've done is I've got myself a bolt that is of a small enough diameter to go down inside the opening of the pinion to be able to push onto the motor shaft. I've drilled out the head of this bolt so that the shaft of the puller can push down into the bolt, and hopefully that will now act as an extension on the puller shaft so that I can continue to draw this pinion off. So let's see how we go with that. Okay, it's very nearly off. Okay, I just need a slightly longer bolt to get down in there. So how deep is that? Oh, so tantalisingly close, about 2 mil short. Okay, so that was the bolt that I'd adapted. I'm just going to do it with this one now. I should have just done it with this one in the first place. As you can see, just got to drill out the head to create a anchor point for the puller shaft to push into. Okay, there you go, there's that drilled out, so the puller shaft will bed itself into there nicely. And then, as you can see, that slots down into there sufficiently that we'll be able to pull that pinion off now. There we go, and it's off. And there's the shaft of the motor. Yeah, so that's a 6 mil shaft, and the pinion, yeah, 6 mil. Okay, so we can now look to source a suitable replacement pinion and spur gear. So here we are, here's the spur gear that I took off the pressure washer. It's a 50 tooth. From what I can work out, it's mod 1 tooth size. It's 10 mil in thickness. It's quite a lump, you know, that's a pretty sturdy piece. And then this is the pinion that I pulled off the motor. It's got a 6.35 shaft in there. 11 tooth. I believe it's roughly 14mm in height, but it was only using just shy of 10mm of its depth to engage with the spur gear there. Anyway, both of these were, I think, what they call interference fit. So, you know, the tolerances between the size of the bore and the shafts they went on were such that they had to be forced on, and that they didn't require any locking in place, that they effectively interfered with one another and locked in place. So anyway, that's that. What have I managed to source? Well, I can't buy replacement parts for the pressure washer. They don't do them anymore. Even then, if they'd done parts, it was buy a whole new motor complete with the pinion attached and no torque of the spur gear. So it left me in a bit of a difficult position. So anyway, what I've done is I've sourced some replacements. This is a steel spur gear. It's a Mod 1 50 tooth, 10mm thick. Yeah, like for like. Only difference is it has an 8mm bore. So I have got to drill this out to 17mm. Now the chances of me drilling it out to the same spec as this, which is interference fit, it's unlikely, but we'll see how we go. And then likewise, the only pinion I could find was really from the RC weld. Again, it's Mod 1, 11 tooth. It's a bit taller than the existing one. And I've already tried it. This 6.35mm shaft fits on perfectly to the motor, but not as an interference fit. But luckily this ships with 2 grub screws. And what I intend to do is to put 2 flat spots on the shaft of the motor in order to utilise these grub screws. And then what I shall have to do is just reduce down the height of this to 14mm as per the other one. And luckily the grub screws are in the 4mm of tooth there that doesn't engage with the spur. So we might just get away with it, subject to boring this out and managing to get this to lock on to the shaft. But we'll cross that bridge when we come to it. Right, and so in order to drill out the spur, I've already got a 13mm drill bit and every variant up to 13mm, and then I also acquired a 15mm and a 17mm. So the plan is to start drilling that out in incremental bits and work up to the 15. Well, I'll work up to the 13, then I'll go with the 15, and then finally with the 17. But I think what I'm going to have to do in order to ensure
I get this hole drilled truly in the centre,
I will drill a couple of holes here and here in this spur gear so I can screw this to a piece of wood that I can hold on the pillar drill a lot more accurately in order to ensure that I'm drilling the centre directly. Because what we don't want is this to have a
off-centre hole and spin
a bit wibbly wobbly. But hey, I'm just a hobbyist in the garage, I'm not a machinist. I'll try my best. Okay, right, so I've now drilled out my new gear to 17mm. I've got to be honest, that's the biggest hole I've ever had to drill in the thickest bit of steel ever. That's a first for me. Right, let's get this off of there. Right then, let's see what the tape says. Right, so the old hole, 1712, 1710. New one, here we go. Okay, 1718. So I'm hoping that's about the same. Right, so there we are. Old gear, new gear. I've put a bit of a bevel on the inside of there. So I have got to get this new gear onto this shaft. The gear goes between this bit and this ridge, and it's just an interference coupling. So I just got to hammer it in. So far so good. was pretty straightforward. I think that's about right. Okay, we could be in business. Okay, now we need to deal with the pinion gears. This is an 11 tooth. I've acquired myself an 11 tooth pinion, and as you can see there's a fair bit of difference in length, but other than that it's the same. Now this is 6.35mm shaft, and it fits onto the shaft of the motor lovely, but it will use these grub screws here to tighten the pinion on. So I'll have to put a couple of flat spots on the shaft of the motor for these grub screws to engage to, and I'll use some Loctite on those grub screws to keep them in place. And then fortunately, as you know, like the other one, because that last third of the pinion doesn't engage with the spur gear, those grub screws won't be an issue. Okay, so what I need to do is to cut this down to the required length. So the original pinion 13.9, so just shy of 14mm, and the new one is 18mm. So I've got to trim a bit off of the end of here, put a couple of flat spots on the shafts, and then that pinion should be all good. Right, okay, so I've mounted the pinion onto a drill bit so I can then hold it in the lathe. I've set my cutting bit there to the 13.9ish mil, and I'm just going to start putting an indentation on the pinion where I want to cut. I'll probably finish the cut off with a saw off of the lathe, but I'm certainly going to make a start here. So let's get the lathe turning. Okay, let's begin to feed in the cutting bit. It's just started to engage. Very close now. And there we are, it's separated. So there we are, there's that pinion cut down. Not a bad cut. Certainly very square and true because of doing it on the lathe. Right, okay, now to put the two flat spots on this shaft in order for those grub screws to engage. And if you look at it like that, the grub screws are at 90 degrees to one another, so just need to put flat spots at 90 degrees to one another on that shaft. Right, okay, so the flat spot doesn't need to go any further than 6mm along the shaft. So here we go. Okay, so there's the first one, and we just rotate it around 90 degrees and go again. There we are, two flat spots, 90 degrees to one another. Let's try the pinion on there. There we are, there is the pinion on. Okay, just got to remember to put some thread lock in those. Right, okay, now we've got to put the spur gear back in there. Right, so we rougher it in. We want to be sure that we don't bash that bearing out of there, so I think I'm going to put a socket in there to hold the bearing in place, so that when I hammer down on there, the socket's held in place. There we go, that should do nicely. So if I place that there, put that over the top, and then I can hammer down on here. Yeah, it's definitely gone in. Okay, you can see it's there now. Well, there's been a bit of a snag. Whilst hammering this into there, it dislodged the spur gear. There is no longer any friction fit. Look, it just comes off. But that is of no use, because if that spur gear doesn't engage on that shaft, nothing's going to work. So now I've got to think of a way of keying that to that shaft. Right, the current plan is to mill out some notches in here and here, so that I can then bore a hole through this shaft, put a rod through it that sticks out wider than the shaft, so that when you push the spur gear on, the protruding bits of the shaft go into the milled out holes and locks the spur gear in place. Right, well, first things first, I'm just going to grind a little flat spot on here so that I can line a drill up. It'll have more chance of seating exactly where I want it to be. Okay, I've got my shaft set up in the pillar drill. Okay, now we go for the 4mm drill hole. There you go, there's the 4mm hole all the way through. Right, okay, so there's the 4mm hole drilled through there. This is a 4mm drill bit, as you can see it passes through. So what I'm going to do is I'm going to cut the shank off of this drill and use that as my pin. And then we just need to put some keyways in there. Clean up the end of the shaft now. I've got it in a drill. I'll spin it around and use the angle grinder. Okay, now so as you can see, I've got the locking pin through the shaft and I've just got it resting in a little bit of the spur gear, so we can now get the line onto the spur gear. Made some markings. I've just got to mill out some recesses for that locking pin to recess into. Right, okay, I've got the spur gear mounted back on a bit of wood. I've got a mill bit in there and I'm going to try and create notches either side of the hole. I've had one attempt and it didn't quite work, so spun it round, starting on a clean bit of the spur gear. Let's have a go. Let's try the hole on the other side now. Right, so there we are. After much mucking about, I have put a locking pin through there. You see this recessed in there. I did make one mistake. See that hole there and that one there weren't quite lined up, so I had to have another go. Whether I've got that quite at the right position on the shaft remains to be seen, but it is certainly locked on now. We can get it back in there. Right, so let's try again. this is the unit that actually deals with the flow of water. Okay, so the water goes in here, through there, goes into this section here, and this section here is what generates the pressure. And then the high pressure water comes through here, down there, and out your hose and out your wand. Now what we've got up the top here is a micro switch, okay, because we don't want the motor to continue turning, generating high pressure water when you have released the trigger of the gun and no water's flowing. Okay, so the moment you stop letting water flow out of the gun, high pressure builds up in here, and then there's a pin here that gets forced that way, and that trips the micro switch, which turns the motor off, which stops the higher pressure water. Then the moment you pull the trigger on the gun and water starts flowing, the pressure in this chamber is released, the piston comes back, the switch is released, and the motor turns and generates the high pressure again. So if I lift up this cover here, you can see a fairly standard micro switch in there, and I've detached this, so if I pull this off, you'll see that there's a rubber cover there, and if I push that in and out, you can hear the switch go. And then in the end of there, you can see that white little piston. That's the rod that gets pushed up to trip that switch. And I can show you this working in action. So this is plugged in. I've got the micro switch pressed in with a screwdriver there. And now if I turn on the unit, okay, nothing's happening at the moment, but the moment that I release the micro switch, the motor starts. Okay, sorry about the noise, it's extremely noisy. So push this in and out. So we know the motor's good, we know the micro switch is good, everything about the motor and switch inside is fine. All that's left to check is that the little plunger in the water flow unit is able to move freely. Right, so I've got the unit in the vise, and I'm just going to unscrew this out. Okay, so there is a washer on there. Right, now I'm going to undo these 3 bolts. Okay, so we have the outlets for the 3 water chambers. Okay, they look like they have springs and trapped ball bearings in there. Yeah, they must move under water pressure. Then in here you've got the seal. There is some calcium deposits built up. Probably want to clean that out. We have quite a large spring in there around the plunger. Okay, that's what offers the resistance for the plunger moving that way. Yeah, so this plunger must be able to move that way with a build-up of pressure pushing it. Right, okay, so there's the spring out of there, and one would imagine that this white nylon plunger should be able to pull out, but it does seem to be rather stuck, which would suggest that that is why maybe this machine chewed up in the first place. Maybe it had a period of not turning off, and then those gears just grinding themselves to pieces. So let's see if I can get this plunger dislodged. Right, okay, so the plunger was in 2 parts, and then we have the unit there. Yeah, so I think there's a bit of calcium built up in there. If I clean it all up, it should flow better. Right, okay, some wire wool, push it down in there, see what we can do. Well, it feels a lot smoother. Just put a little bit of oil around there. still very stiff, but then again we're talking about a lot of pressure. It's not as stiff as it was. Yeah, getting much cleaner in there now. So yeah, I've just taken the rubber seal off the side there. Just going to give this a wipe around. Get off any calcium that might have built up around the side of this. Get that back on there. Yeah, definite improvement. Alright, I'm just going to put some silicone grease around there. And let's put that back in. There we go, that can move nice and freely now. Okay, so the spring goes back in, and then this nylon top thing, and we can put this back in. I'm just going to smear a bit of grease around there, give that a little bit of lubrication. Bit on the plunger itself. Let's do that back up. Okay, just a nice interesting point here. There's actually a bypass here. So if I blow through the water inlet and cover that up, I won't be able to blow through. But if I uncover that hole, there you see, so there is a bypass, and then it marries up with there and then there. So you'll notice that when you're using your pressure washer and the engine's not running, or the motor's not running, you can pull the trigger like with no power on, that is, and water will still come out of the jet. So that is working through the bypass. Okay, let's just put a bit of silicone on these seals. Okay, right, it is back in bits again, and the reason being is I'm struggling to keep the pinion attached to this motor shaft. Okay, so the machine was running all good, everything had proven to be fine, but the grub screw, it threw the grub screw out of the pinion, even with Loctite and stud lock, and then that grub screw whizzed around and chewed up that spur gear that I'd manufactured. So I had to start again. Made a new spur gear, that's all good. Put a new pinion gear on there, but again it started to slip after about 15 minutes of usage. So what I'm going to do, I'm going to ditch the grub screws off of there. I'm going to put the pinion on, and I'm going to try and weld it on. If this doesn't work, then it's getting scrapped. So the welder's on. Let's have a go. Right, okay, I'll just take the angle grinder to the top, trying to take the excess off. Okay, right, well that's the pinion there, all welded back onto the shaft. It remains to be seen how well that holds. I have offered back on this unit to make sure that the pinion and spur still mesh up all right, and it seems to be fine. So let's get it all back together. Right, it's all back together. Let's turn it on. Okay, set back again. The weld did not hold. The weld didn't penetrate deep enough. It was literally just the end of the shaft and the top of that was tacked on, and then when I ground it off, I ground a lot of the meat off. So back to the drawing board. Now what I'm thinking is I'm going to put a proper flat spot on this shaft. I'm then going to put the grub screw in, sink it in deep. If I put enough of a flat spot on there, I can sink the grub screw in there deep, then weld the grub screw in. Fingers crossed. Okay, so that's a nice flat spot put on that. Now the pinion can go on. I can do up the grub screw and it should go into the pinion quite some way. Yeah, so it's recessed in there quite deeply. And then if I put a weld in there, and the pinion has come off once again.
No, it wasn't the pinion was fine. The problem is with the spur gear.
As you can see, they come with, I think that's an 8mm hole, and the original is a 17mm or there or thereabouts. And try as I may so far to drill out the centre of these holes perfectly true, they're always a little off centre. What happens is they chew up because that gear's going around like that effectively, and the meshing isn't quite right, and they chew up. So as you can see, I've had 2 attempts so far. I am, like a fool, going to try for a 3rd time, and I am going to try and come up with an ingenious method of trying to ensure that I drill through the middle of that accurately. Now, I could cheat and go to someone who's got a proper big lathe. Unfortunately, my little mini lathe that I've got up there isn't up for doing this, so I'm using this pillar drill. So anyway, yeah, got to come up with a method of getting that drill through there correctly. I think if I can get this hole in here perfectly centered, I think we might be onto something. Also, what I'm going to do is I'm going to try and heat treat this spur gear, heat it up, dip it in oil, heat it up, dip it in oil, just trying to harden it, because yeah, I think my pinions are of a harder material than my spur. Certainly with the original pieces, they're of the same material, which is a much better situation. So anyway, let's try and drill this hole, and if it don't work this time, that's it. I'm quitting. Honestly, I am, I promise. Right, okay, so I've made my first update to the shaft itself. Now I've drilled a new hole for the locking pin, which is lower, which means I don't have to rebate the spur gear quite so deeply. I can do a shallower rebate, and it's more accurately drilled, so it's level, it's in there. Now with the existing holes, I've threaded them, and as you can see, I put these M5 screws in. Now what I'm going to do is I'm going to angle grind the heads off and grind down so that the threads are flush to the shaft, so they lock my retaining pins in place. That is nice and secure in there now. And then when the screws are cut off and ground off, they will be trapped in place when the spur gear is put on the shaft. Okay, so there we go. Bolts have been ground off. That pin is now locked in place. And right now, back to the important bit. Let's try and get this spur gear sorted. Okay, in an effort to ensure that I drill this hole perfectly in the centre of this gear, I've made up this jig that I've set the gear on. So the gear will always be perfectly in the same place on the bed. Now, that is an 8mm drill bit, and the gear shipped with an 8mm shaft, so we know that that's all lined up. Okay, that perfectly turns. Now what I need to do is ensure that whenever I move this bed to put a larger drill in there, because obviously for a longer drill bit I have to drop the bed down, I need to make sure this gets back into this position. So what I need to do is, using the 8mm as a reference point in the chuck, create a reference point on here that I can line up to this. So I have an idea. Right, so here we go. So I've created this bridge across the piece that I want to drill, and I've got an 8mm drill bit in there, which you can see goes through a hole in the wooden bridge across there. And if I lower the drill, you can see that my drill bit then perfectly enters the 8mm shaft hole on the piece that I want to drill. So now I have got a permanent point of reference that, in the event that I need to move the bed of the pillar drill, which I undoubtedly will need to do in order to get these bigger drills in, I can re-establish the position of the bed using this reference point with an 8mm bit in it, so that I always continue to drill perfectly in the middle of my spur gear. Well, that's the plan at least. Okay, now I've got my point of reference set, I can now look to start drilling. Now, the spur gear has a 8mm shaft hole already, so that is the 8mm drill. Don't need to drill that obviously, but I shall be using that to establish point of reference at various times. I'm now going with a 9, an 11, a 13, a 15, and then finally to my 17, which is the final bore size that I need. Now I could go in 1mm increments up to the 13, as I have each individual millimetre increment up to that point, but once I get beyond 13 I jump to 15 and then 17. So, you know, if I'm content with jumping 2mm at this point, well, I might as well do the 2mm jumps at this point as well. So as I say, we're going to go 9, 11, 13, 15, 17. So let's crack on. Right, okay, in order to get the next size in, which is the 11mm, I've got to drop the bed down. So I've dropped the bed down, I've put the 8mm back in, put the bar back across, the bridge back across, and you see I've got my point of reference, so I know the bed is in the right position. So I can now take that out of there, swap over the drill bits for the bigger one, put the piece back underneath, and when I lower that down, that should be lined up pretty perfectly. Okay. Okay, now time for the 13mm. Okay, now time for the 15mm. Okay, now finally the 17mm. Right, okay, now I've bored the hole through the middle of this new spur gear. I've made it as much in the middle as the spur gear as possible. Seems like an easy thing to do, but in reality it's not if you haven't got a mill or a lathe, I should say. So anyway, that's the shaft it's going to go on. It goes like that. Okay, as you see, I've put these prongs, or I'll put a prong right the way through there. That will lock this spur gear onto this shaft, okay, because the original spur gear was like an interference fit, which I couldn't replicate. So anyway, in order to get these lugs to lock into this new spur gear, I need to rebate out the back of the spur gear in order for them to go in. Now I want to rebate out to the depth equivalent to where I want this to sit on the shaft. So I want the spur gear to go down to this notch. So I've got to rebate out the measurement from that line on the shaft to the top side of this little notch here. So vernier calipers to measure that. Measure up where I want the cutouts to be, and let's crack on. Right, so the plan is to mark where these notches are, or pins, or whatever your lugs want to call there, on the spur gear. So I'll mark one on this side, like that, spin it around, and then mark one there. Okay, so we have a mark there and there, and I can draw a line across. Now it's a notch across there. Now I could literally angle grind straight across there, so it doesn't really matter whether the notch or the rebate ends where the pins are, because that pin is trapped. In an ideal world it would, because then the spur gear would definitely trap the pins, but I'm going to try and mill it out without a mill. Right, okay, so I've mounted the spur gear to this bit of wood. Okay, there's the line that I want to mill out. Okay, so I've mounted that line perpendicular to the edges of this bit of wood, and I've screwed these two guide bits of wood to this sort of wooden block I've got attached to my pillar drill here. You saw this earlier when I was drilling out the spur gear. What I can now do is slide this bit of wood in between the two. Okay, as you can see, it can slide back and forwards like so. And for the moment, I've just got the 17mm drill bit in there like so, just to prove that I have centered the spur gear to the pillar drill. So when I put my milling bit in there, the milling bit will be on the center, on the line that I need to mill out. And as you can see, I can now slide this backwards and forwards like so, in a hope that I will mill out the little slots that I need in this spur gear in order to lock onto that shaft. That's the plan. Right, okay, now I'm all set up with my mill bit. First thing I'm going to do is plunge cut at the furthest point that I want my mill to be done. So I'll plunge cut there and a plunge cut there, and then we'll try actually milling in from the centre to the plunge cut. So here goes. Okay, so what I've actually done is I've just put this bit of wood across the back here. That will stop the sled from moving that way, which is the way that the rotating bit wants to drag the piece. Right, well, it turns out that my mill bit, which is a 4-flute mill bit, was actually broken. There's only like one cutting edge left on the tip of this, so it looks like I've used it before and abused it and broke it. This is actually HSS, so that can go, and I've got myself some tungsten carbide bits. So you can see that's still got 4 cutting bits attached. So let's get this in there and let's try again. Right, okay, there's my whole sort of plunge cut down. Now what we need to do is see if we can actually slice the groove in. So there's not much material there to take away, so we'll do it at incremental depths and see whether this will actually mill out. Right, okay, so I've dropped the bit down to my first depth, okay, and I'm just going to see whether that will slice cut this. Start it up. Okay, now I just need to drop the bit down a bit further or raise the table up, either way. There we go, that's the next depth done, so we'll keep going. In an ideal world I'd raise the table up because obviously the bit's getting longer and we're putting more of a strain on it. But if I move the table I will lose my centre. So I'm going to do it this way. Right, okay, so there's my notch cut out on that side. I've just got to do this side now. Right, so here we are with the notched out slotted spur gear, and here's my shaft. So that goes in like that. Let's hammer it home. And there we are, all seated together nicely. The spur is sitting exactly where I wanted it to sit on the shaft. Nice tight fit. Right, okay, so I've taken the spur gear back off of the shaft for the time being, put that over there. And here we have the original spur gear. As you see, it's all chewed up. Now what I'm worried about is the hardness of this metal. This is the original gear, and if I take this pin, I can't scratch the surface of that. Okay, so that's quite hard, and it's still chewed up. This gear, okay, I can run that steel pin across there, and you can see it is marking the steel. So what I would like to try to do is to try and case harden this a bit. Now it's quite, you know, technically it's quite involved. You know, you're getting into the realms of physics, but fundamentally what you're looking to do is heat this up, and from what I've read, really you need to be heating it up to like 800 degrees C plus, and then quenching it quickly, cooling it quickly, either in water or in oil. Now oil cools it quicker, and water cools it quicker and forms a harder steel, but it cools it quicker and you run the risk of creating stresses in the metal, and so potentially you can distort your piece. Or you can quench in oil that also cools it but not quite so quick, and you have less chance of stressing out the metal. Now really for my application with this, I'm just going to go quenching it in water and see how I get on, and it's whether I can even heat it up to the required temperature. I have got a thermometer gauge, but I've got a sneaky suspicion that this only goes up to 600 C. So all we can really do is know that we're north of 600 C using this thermometer gauge. But anyway, yeah, we're going to heat this up, cool it, heat it up, cool it, heat up, cool it, and then finally you're meant to do a process where you heat it up again and just let it cool naturally. So anyway, let's crack on. Right, so here goes. I've got my spur gear hanging there. I've got my tub of water for quenching. I've got my infrared temperature gauge. As you can see, my hand is 25 degrees, but the piece is only 10 degrees at the moment, and I have my blowtorch. So let's get heating up. So we're only at 160 degrees at the moment. Okay, we're up to 200 and something. Okay, let's try it again for a bit longer. Right, well, there's the spur gear back on the shaft. I'm not really sure how much hardening actually happened there. I'm not sure I could get the temperatures up high enough with that blowtorch I had, but you know, it was worth a try. You never know, it might be a worthwhile thing to do. So anyway, let's get this all back together. Let's build this pump all back up. Goes back together as I dismantled it, and let's see whether I've actually fixed this pressure washer. Right, okay, now before I put this shaft and spur gear back into its housing there, one thing that's kind of bothering me is that these pins on the back stop the spur gear from rotating on the shaft, so that it's locked onto the shaft in a rotational way. But other than a little bit of tight tolerance, there's nothing to stop this spur gear raising back off the shaft. This bearing goes on there, and there'll end up being about a 6mm gap between the bearing and the spur gear. Now potentially, with the right forces, this spur gear could raise up along, or move along that shaft, and cause all sorts of damage. So I've got to come up with a way to try and key this onto the shaft to stop it moving in that direction. So the current plan is to try and drill down between down there, so that effectively you're drilling through the spur gear and the shaft, put a screw in there, whip the head of the screw off, and then that will key that in place. Probably have to do it on both sides to balance it out, otherwise there might be an imbalance. So anyway, let's see if we can do that on the pillar drill. Here we go, so we've got the piece clamped on my pillar drill. Let's see if we can't drop a drill hole down through there. Okay, now we've made a start, I'm just stepping up to a bigger size drill. and now one drill bit bigger. Right, as you can see, I successfully drilled out a hole that goes through both the spur gear and down the side of the shaft, and I have threaded it with a tap and die, and there I have put this screw in. Okay, now what I'm going to do is slice that screw off with an angle grinder, and I've decided I don't need to do on the other side because the screw just takes up the material that I've drilled out, so there shouldn't really be too much difference in weight because the heads and all that's going to come off. So yeah, I'm going to whip that off with the angle grinder. So as you can see, that screw now locks down the spur gear to the shaft, and we shouldn't get any movement that way either, and it will just aid the keying on. Right, we can get this back together now. Right, there you go, the new spur gear and shaft is back in its housing. I've got the support bearing on in place, and yeah, it's in there nicely. It all rotates round, and then on the reverse side I've started to get the wobble plate back in there. You can see the base of the wobble plate, you see it goes around like that, and I've just got to put in the bearing so that drops in like so, and then this top bit that runs around on those bearings goes in like that, and then we put gear oil in there, and then this is the actual pump mechanism that goes in like that, and that wobble plate turns around like so and pushes these up in turn. Okay, and then they come through and they hammer the water through there, and that creates the pressure. So fill this up with oil, get this back on there, get it all back together, and let's see whether this thing works. Okay, that might be a little bit too much because you're going to get the old eureka effect as that plunges in there. We shall see. And there you go, that's all back on there and filled with oil, and you can see these protrude through, and as I turn this spur gear you can see how the pistons go up and down. Okay, and that creates the pump. Right, okay, now that's all back together, we can now get this water inlet outlet mechanism back on. Okay, so that goes onto the pump like that, and then that pushes on like that, and it's just a case of putting these bolts down through there. As you saw, there was a broken one at the very start of the video, and I've sourced a replacement screw for that, so in they go. Okay, so that's all back together. We can look about getting this now into the actual power washer. Right, okay, so before I put all this back together, I've just tidied up the welding on this pinion gear. So I turned the motor on, had the pinion running, and then I just put the angle grinder on there just to take off some of the roughness of the welding. So we've now got only clean teeth there to engage with the spur gear. Right, okay, now it's time to put the pump unit back onto the motor. I've put the rubber seal back in there. Now this goes on like so, like that. Okay, and then these bolts just go through. Like that. Okay, so this goes back into its housing. Okay, now then this plastic mount fits onto the underside of there, locates on lugs on the moulding of the casing. This one goes over the top and a couple of screws go down through there. Right, let's drop these two screws down into here. Like so. Right, I've got it plugged in. For the moment the pressure switch that attaches to the water outlet is detached, so it will allow me to run it. So let's switch it on. Seems to be running. Well, there it is, all back together. All that's left to be done is to take it outside, connect up the hoses and see whether it actually works. Let's switch the machine on. The machine is on, the motor is not running. I pull the trigger and straight away it turns on and off. Well, there you go guys, there is my Draper pressure washer fixed. And I've got to be honest, I am massively surprised because I was so dubious and doubtful during this whole process whether this thing would stay together. I thought maybe it would bust itself to pieces, but it's working, and it's, if anything, it's working better than ever. The motors turn on and off the moment you press and release the trigger, and that's, I'm assuming, is largely due to the fact that I cleaned out that plunger that activates the micro switch, and I think that was probably what done for the machine in the first place. I think that plunger had become stuck, and then the machine was just running and running, got hydraulic lock, I think that's the term, something like that. So the motor's spinning, the pistons are pumping, it's producing pressure, but there's nowhere for that pressure to go, and I think ultimately that bust the bolt off of that, the head off of that bolt, which we saw earlier in the video. So yeah, it's working. I can't believe it. Was it worth it? Arguably not. I could have probably just gone down to the local shop and bought a new one. In terms of the time and effort that it's taken for me to fix this, you know. But look, I'm a tinkerer, and I've really enjoyed doing it. I've proved to myself that even in a domestic garage with, you know, a relatively rubbish pillar drill and a makeshift workbench, you can fix some pretty big things, major things, you know, and you can do things just a little bit beyond the norm. So I've really enjoyed it. Thank you for bearing with me and watching it. I know it was probably a long, tedious video, but I'm super stoked, really am. So thanks again for watching. Please be sure to give me a thumbs up for this one, and like and subscribe, and hit notifications if you haven't already. Check out some of my other videos, and I shall see you again very soon when other things around our house have broke and I fix and film them. See you soon. Bye bye.